Assalamualaikum and good morning. Today we group 11 will talk a little bit about rocket engine propulsion. In this video we'll talk a little bit about rocket engine history development, and then we will talk about its design and specification, and we'll touch a little bit about thrust engine equation. So basically rocket engine propulsion main purpose was to generate force, to be precise, to generate thrust so that an aircraft can move in the space. In early development of rocket engine, a Russian scientist, Konstantin Tsiolkovsky, he formulated and led theoretical foundation of rocketry, and because of this, he was called the father of astronautics. This marked the early history of rocket engine. Then, the next person, if Constantine is starting for theoretical study, Robert Goddard bring the theory into something practical. He conducted various experimental studies, and as a result of that, he made significant progress in rocketry, and more importantly, practical development. Hermann Oberth, he was a German, also one of the fathers of rocketry. Like Constantine, he also formulated rocket equation, and his theoretical contribute to the advancement of rocket science. Germany also, Werner von Braun, he was a key figure in the development of Nazi Germany's V2 rocket. To put it simply, he played a vital role in the space race in the mid 20th century, and this was during World War II. Then moving to the next person, Theodor von Karaman. He also befriend to the key figure that I mentioned before, and collaborated with Robert Goddard and also Jack Parsons in 1930s, contributing to the understanding of rocket propulsion and the potential for reaching high altitudes for rockets. And lastly, a Soviet engineer and chief designer Sergei Korolev, and he, for his history, his most notably contribution was to lay the groundwork for the first human ever in the space, and this was Yuri Gagarin's historic orbit in 1961.
Moving on to the design and specification of the rocket engine, here's a few design features that need to be considered in designing an engine. Firstly, the nozzle geometry. Nozzle geometry is important for ensuring for maximum thrust efficiency. Using the Nernst principle, we need a high velocity to launch a rocket. Therefore, nozzle geometry are important to increase the jet engine efficiency. Next, we have combustion chamber that were designed for controlling the combustion dynamics. Combustion chamber holds the difficult task of bringing large quantity of fuel and release energy to drive the rocket engine. Third, we have propellant delivery to optimize system with stable flow and pressure. And lastly, we have thermal management, where in the jet engine, using this feature is important to avoid overheat in the engine.
Now we are going to talk about the theoretical concepts. Theoretical concepts is an understanding of fluid mechanics that help us to grasp how these hot gases create thrust to propel the rocket. First, we are going to talk about thrust generation. Thrust is generated by the expulsion of hot gases from the rocket engine nozzle. The thrust generator is proportional to the mass flow of the propellant and the velocity of the exhaust gases. Second is propulsion efficiency. Propulsion efficiency refers to the ratio of the thrust generated to the amount of propellant consumed. Higher propulsion efficiency equals to more thrust with less propellant. Propulsion efficiency is affected by factors such as nozzle design, combustion efficiency, and the specific impulse of the propellant. Third is combustion dynamics. Combustion dynamics refers to the process of controlled combustion of propellants within the rocket engine combustion chamber. The combustion process generates high temperatures and pressures, which can cause the instabilities and fluctuations in the combustion process. Among the challenges we met are the need for advanced technology and engineering, the difficulties of simulating extreme conditions on Earth, health risks to astronauts, and hazards in spaces. We also get some extra opportunities such as scientific discovery and innovation, inspiring and educating the public, fostering international cooperation, practical application on Earth such as developing new materials and technologies.
So, thrust equation of rocket engine. The momentum equation for steady flow is given by F equal to m dot VE plus PE minus PA bracket AE. Where is it? F is the thrust, VE is the velocity component at exit of nozzle, M dot is the mass flow rate of propellant, PE is the pressure of exit plane of nozzle, PA is the ambient pressure, AE is the area of nozzle rocket. Next is the effective exhaust velocity. F equal to M dot VE and the next is the effective exhaust velocity VE. VE equal to F over M dot equal VE plus PE minus PA over M dot darab dengan AE. So the last one is the effect of divergence angle on thrust, iaitu F equal to 1 plus cos A over 2 M dot VE plus PE minus PA bracket AE equal to lambda D M dot VE plus PE minus PA AE. So where the lambda D is the divergence correction factor whose values are closer to unity. So that's all from us. Thank you for your attention.